Hungry Trilobyte podcast would like to start by acknowledging these fine conventions.
SoonerCon. SoonerCon is Central Oklahoma's longest-running pop culture convention. It is held in Norman, Oklahoma, and the next event is scheduled for June 24th through 26th, 2022. You can go to SoonerCon.com to sign up and get early bird pricing on admission. The Hellmouth Convention. The Hellmouth Convention is a celebration of fandoms such as Buffy, Firefly, and Dr. Horrible. It is scheduled for June 3rd through 5th, 2022 in Los Angeles, California. All proceeds raised will benefit various charities. Please go to thehellmouth.org for more information.
Back today, we have Dr. Mohamed Noor. How are you this evening?
I'm great. Thank you for having me back. I always like being on the Hungry Trilobyte.
Well, I was really excited to see you again on the Star Trek cruise last month.
Yeah.
It was an amazing experience. And you talked about so many things that I wish I could have bent your ear and just gotten in on. Did you have a good time?
I had a great time. I'm sorry we didn't get to do a recording there too. I mean, it was definitely, especially the last day. The last day was crazy.
You were very busy.
Yeah.
I mean, your schedule was packed. So
yeah, it was fun. It was super fun. I had a blast.
But a lot of I had an absolute blast. I was on Star Trek Cruise 3 and then 5, missed the one in the middle.
I did
but
4. Yeah, but
it's gotten better and better.
Yeah. Totally agree.
Anybody who wants to go, strongly recommend it. Give me a shout. Call me. Yeah.
2 thumbs up.
Yeah. You got into a lot of really neat lectures on there discussing things that I personally think are the most fun topics when it comes to science fiction, especially Trek. People talk about the warp engine and they talk about transporting, and those are great topics.
Yeah.
But maybe I'm simple, but I like to just think, is it possible there's life on other worlds?
Oh, yeah. Well, as a biologist, obviously, those appeal to me more than the transporters and warp drive and things like that, too. Even though those are super interesting. But
yes,
I love the biology aspect. I love, what would we see if we went to another world? And this is the timing was unfortunate in terms of the cruise, because initially it looked like the cruise was going to happen after Star Trek Discovery finished its 4th season. But things got rearranged a little bit in terms of the Discovery releases, so that those aliens, which came out the very, very end of season 4 of Discovery, weren't shown by the time we were on the cruise, so we couldn't talk about those. It's like, oh man, it was so close.
That is unfortunate. And I was just sitting there wondering, when you go to your day-to-day and you literally write professional works on what life is like on this planet.
Yep.
How useful is it to just sit and ponder these things? Is there an academic benefit to just sitting and spinning your wheels on it?
On which part? On
any of it? Just sitting there thinking, what would life be like? Is there life out of the world?
Oh, in terms of astrobiology, yeah, yes. Absolutely. Now that's I like you said, my research is completely on speciation and related evolutionary processes on Earth. There are people who actually do focus specifically on astrobiology or exobiology, and specifically focusing on first principles of what might we see on other worlds. And that has huge benefits, because we haven't seen it yet, and we don't actually know. And what would be one of the terms that they often use, and this is not my subfield, but in that subfield, one of the terms they use is agnostic biosignatures. Like, essentially, like if we were to find some sort of truly alien life and it's not like our life, because we always are like, well, we're looking for things that are water-based, carbon-based, all those things, but it doesn't have to be. So what would a biosignature be that is not reliant upon what we know about our world, but trying to come up with it almost from first principles? And that's a fascinating area. I wish it was my area, but it's not my area.
Sure.
Well, I love my area too. Yeah, nothing against my area, of course.
Yeah, I'm just sitting here thinking, because from my complete layperson's perspective here, the next step is we hear about silicon-based life as a one-off from carbon-based life, and that's as far as my imagination can take me. If there's something beyond even that, I don't know. But is there even DNA if you get to that point, or is that carbon?
Probably not. DNA is still carbon-based. It has a backbone of all these carbon compounds. So probably not. And there's challenges with silicon-based life. People talk about it's just one down on the periodic table. But if you have a water sort of environment, silicon would prefer to bind with oxygen over other silicons. The advantage of carbon is not just that it binds to 4 other atoms, that's huge, but it also it can make these long and complex chains and things like that. Silicon is not quite as good in that regard, especially in the presence of oxygen or water or things like that. So
And to say it's only one, one slot down on the periodic table, it's like, well, at the same time, there's only one molecule of difference between water and hydrogen peroxide, and that's a big difference.
Fair point. Absolutely. Yeah, go ahead.
No, I was just thinking idly here, is if we don't have DNA, where do we store the building blocks? And silicon stores literal memory that we use here on Earth in computer form.
It's true. That's true. Now, of course, that was much more like designed as opposed to something that was a byproduct of just natural processes. But yeah,
sure. And that's a philosophy way beyond what I'm thinking here.
That does open up a whole can of worms.
Yeah, no, don't want to go that route. Just thinking what is possible, regardless of how it comes about.
It's hard to know because, I mean, to some extent, what you want is some sort of heredity. I mean, that's what the DNA is giving you. It's giving some sort of heredity. Then it's giving the opportunity for things like natural selection to work. That basically something about me is passed on to the next generation after me, right? So that, yeah, I mean, could something else do that? I mean, to some extent, if you go back, I mean, I guess one way of looking at it is the other direction, going back in time. Before the 1940s, we didn't know that DNA was the hereditary material of life. People thought maybe it was proteins, maybe it's these other things. So, I mean, at least at that point in time, from first principles, people thought that maybe these other things could do it. Now, proteins, of course, are still carbon-based. That doesn't change that aspect to it. But it does open the question of what else could have that sort of information content. RNA is an easy one because to some extent, RNA has the ability to, make other copies of RNA, but also can, essentially help identify, building blocks that can be built from it. So like our RNA is translated into proteins. So RNA is a good candidate for that. And we have, obviously, on Earth, we have RNA viruses. And it's thought that maybe on Earth in ancient history, RNA was the original hereditary material, was eventually replaced mostly with DNA. But yeah, we don't know.
So, I mean, when it comes to viruses, do we consider them life in the same sense that, animals and plants would be? Yeah.
It's a wonderful question. Yeah, I mean, the comment I always say is like, whenever you go to your doctor, they say they want to kill your viruses. So that implies they're alive. That's the comment I say. Of course, you're working on doctors there rather than evolutionary biologists. Different people say different things. I mean, certainly like on the way to life. I mean, the people who argue against it, I'm in the four. I'll tell you that. And the people who argue against it say, oh, but they can't reproduce on their own. I'm like, I can't reproduce on my own. Right? I mean, I need something. Now, that's not a fair comparison because you can have something that's like me that would help me reproduce. Mm-hmm. But a virus, like, if you give it another virus, it still can't reproduce. So I still think that there's plenty of things that just have special needs. I don't think that makes it not alive. So,
and I mean, when it comes to it doesn't metabolize per se.
Yeah. But it definitely experiences natural selection. Like as we've unfortunately been experiencing lately with all these variants.
Yeah, and that's because somebody once said to me that biology is the only topic that can't define specifically what it studies. It just goes by process of elimination, what's left.
Yeah. I mean, there's if you go to any textbook of biology, they'll usually have these 7 categories of life, but you can always find exceptions to it. Mm-hmm. You can always say, like, for example, one of the criteria for life is that it can reproduce. So does that mean a mule is not alive? Like clearly, like it does. I mean, we consider it alive. And there's a whole bunch, like for almost any one of those, you could probably find at least a gray area, if not an exception in one or the other direction.
And that's when you circle back to where we got off on the topic. Is like, if you ever start to look for what would be completely outside of our sphere, how would we even recognize it? How many arguments would we have just seeing, should we even include it in the conversation?
Yeah. I love one. I know some astrobiologists find this controversial. There's some people who've done these sort of statistical approaches looking at it in the context of complexity, like that there's some kind of sweet spot in the middle where some things are absolutely simple. Like just imagine like some just repetitive thing of like a compound or something like that. They're like, okay, that's clearly not a lot. And other things are like incredibly complex where there's no rhyme or reason or pattern. They're like, okay, that's clearly too complex, but they suggest there's some sweet spot in the middle where there are some patterns and there's some complexity, but it's not ridiculously complex where there's decipherable patterns. That's kind of the sweet spot where you might be able to not necessarily know that life was involved, but at least that would be a good candidate for looking for life. And I like that sort of idea because it's truly agnostic, but I think it's still a bit of a controversial idea even among some astrobiologists.
Sure.
Yeah.
And again, I just kind of wonder because it would be so great if we had the ability to actually look at something and say, okay, this is what we compare it to, but we don't. Yeah. And I'm a fan of thought experiments. That's my weakness of mine. Yeah. And I like that example I just gave you too, because it's truly a first principles idea.
It's not something where you're not comparing it to like an amino acid or something like that. You're not comparing it to something we know on Earth.
I like when you're, to go back to Trek for just a second,
Sure,
there,
please.
and your lectures. I was interested discussing evolutionary biology. That I always want to say, do you have a point at which you can look at a fictional creature and say, this is the reason that biology guided them that way? Where these were the traits that were beneficial, these were the traits that were that had to be dropped from the chain. Is that a thought process that comes naturally, easily?
Oh yeah, absolutely. So I mean, it's yes and no. So I mean, on the one hand, yes, like this happens all the time. People identify like, oh, a giraffe has a long neck and it's useful for like reaching trees or something like that. As the trees get taller, their necks got long. Yeah, that's on the one hand, that's one thing that's done a lot. On the other hand, this is something that, there was a very eloquent paper back in like the late 70s about this particular topic, about this sort of evolutionary storytelling. We have to be very careful because some things can look like they have a particular purpose and we're just wrong. And I forget they used a reference of the spandrels of San Marcos. It was some artistic thing with like fancy arches or something like that. It looked like, oh, this must be holding up the top very well. Like, nope, they're purely decorative. So evolutionary biologists have to be very careful, and you basically have to like develop very, very good hypotheses and then test from them and then do it serially. And to some extent, like, is it ever 100% where this is the natural selection that made this happen? I mean, certainly in some cases, yes. Like if you apply pesticide and then a pesticide resistance gene spreads, like, okay, that's very straightforward. I guess in theory you could say maybe it would have spread anyway, but like, come on. You can have very, very high confidence sometimes. But it's very important to just watch for adaptive storytelling, as they call it, and be very careful about that. Have rigorous hypotheses or rigorous alternative hypotheses that could essentially refute your theory.
Does genome research aid with this at all?
Oh, yeah.
And I say that not saying, because I don't know to what extent, because that's something I've always found fascinating, just being able to say this came from this strain. And
oh yeah, I mean, anything involving DNA is wonderful because the number of tests you can do. I'll give you just one set of examples. There's a million ways that DNA studies can help, and it doesn't necessarily have to be whole genome. The whole genome is always very good too. There's a lot of statistical approaches you can do. Let's say, for example, that you knew a particular gene was involved with, say, insecticide resistance or something like that, and you knew that it had spread recently. There are specific signals that you can see in the DNA. When I say signals, I don't mean something like in the DNA per se, but like statistically, like the distribution of variation in a particular stretch of a gene can be used to interpret what were the evolutionary forces that helped drive changes at that gene. And that's something that's been used a lot for the past like 30, 40 years in evolutionary biology, a ton. So there's a whole field called like basically molecular evolution that really, it was kind of around before the late 80s, but it really after that, it became like, a mainstay in evolutionary biology. So yeah, DNA-based studies and genome-based studies even more so just provide like tons of ways of getting at questions that were never available before. Now, that's not to say that people hadn't done a lot of exciting research before that. And, people had interpreted a lot of things quite well. It, in many cases, very strongly reinforced what people had already inferred. In other cases, it gave new insights that we didn't have before.
I remember when it was 1995, I was in middle school, and we were learning about the Human Genome Project.
Yeah.
It was hot news at the time. And we kept being told this was this big project that was going to take so long.
Yeah.
And then like a couple of years later, it's like, yep, we're done. Wrapped it up.
Craig Venter, he changed the whole thing. I don't know if you remember his name.
I don't.
Oh, okay. Yeah. So he came up with, well, I don't know if he came up with it, but he was part of one of the people who popularized this idea of shotgun sequencing. So what was happening before is they were going through and they were sequencing a stretch of DNA and they were trying to find, okay, where's the next stretch? And then let's do that a little bit. And it was just this like plodding along in the genome. So that's why it was going ridiculously slow. Craig Venter said, you know what? We should just like dice up the genome, into the little pieces, which is fairly easy to do with enzymes or through mechanical means, and then just sequence lots of it without any regard to what we're sequencing, and then computationally assemble it all. That completely changed how everything was working, and that revolutionized how the Human Genome Project ran. All the sequencing that's done today uses at least that principle. Maybe not, the approach is not exactly the same, but uses that principle. It's a sort of shotgun approach. We're just going to dice up the genome, sequence everything, and put it together in the computer, as opposed to plodding around like from base 1 to base 500, then base 501 to base 510, etc.
I'm going to have to make extensive show notes for this episode, but it's so going to be worth it. I'm going to put a ton of stuff in there. When you were talking on stage and we were talking about how beneficial it is to use pop culture as a way to springboard some of your discussions, one of the examples used was the Avengers. And I had to think, gee, how many conversations have you gotten out of the Avengers?
Me personally, not a ton.
Okay.
I mean, the difference between Star Trek and something like Marvel or fantasy in general is there's not an attempt to be that scientifically accurate. Like they're happy to just be like, we'll give you the super soldier serum. Don't worry about what it is. You know, it's something. Star Trek doesn't do that as much. And when it does, it acknowledges what it's doing, right? You know, it'll acknowledge like we're using a save here, like the what is it called? The Heisenberg compensators or the inertial dampeners. So they're acknowledging there's a problem, but they're just kind of using it like, we know there's a problem. We're just going to jump over that. Yeah, Marvel in particular, I don't use a lot, but I know my colleague at Duke, Professor Eric Span, he has used quite a few Marvel things. In fact, he has a whole talk about Captain America's super serum. So I mean, he uses it to try to present things. I find that a little bit harder. He's smarter than I am, I guess.
Sure. I've one of my favorite topics and things I like to go on, and with Dr. N and I have talked about this once or twice, is the need of sometimes the story to supersede the science and the balance you have in between there.
Absolutely. And even with consulting, I've sometimes pointed out like, this is a problem, but like, you know, just let it go. And Dr. Erin has a really good principle that she uses often too. She says, if something is too hard to explain, just don't. It's better than trying to explain it and doing it badly. It's better just not to. Just leave it alone.
I had a buddy who was writing a time travel story a while back, and I'm a sucker for time travel stories. And he really spent like 5 pages getting into this explanation as to how the trip from one point to another took place. And he's like, I don't think the science works out. It doesn't make sense. And I said, nobody's going to care. If it's a time travel story, just like, you know, when somebody travels to that planet, unless it's really important to the story, they don't care why the people are purple.
Yeah.
They don't care why they have feathers, unless that becomes an issue in the story.
Yeah.
And so how often does that come about when you're trying to do a reference that you have to decide, does this really affect the story or not?
I'm not in a position where I have to make those decisions, right? I mean, I'm just a contracted consultant. So basically, if they're asking me, then they feel like that they want something to be put in there. So it's not my place to say, no, just don't. But it has come up though, just in some discussions where like I will suggest something, and I'll say, this doesn't fully work, but just just let it go, even though it doesn't fully work. Just allow that to continue, but you know, it at least gets you close enough where don't worry about, you know, imagine like a road, like you're driving from you know, Washington DC to New York. This gets you all the way to New Jersey. Don't worry about that last leg.
That's a really good analogy.
Thanks.
Because I think it's only been somewhat recently that we've really started to wonder, how close do we have to get these things, especially, you know, using Star Trek as a metric. It's 50 years old. It's got a long enough timeline.
Yeah.
You know, for a while, it was like, well, one guy's black on one side and white on the other.
Oh,
and that's just, like there's not really an evolutionary way we can say that makes sense.
Actually, it's interesting. Professor Eric Span, I was just talking about, has a spring break class that he just ran like here in March 2022. And they actually tried to come up with a way to do exactly that one. They tried to science that out and have some explanation for it. It was a stretch, but you know, hey, kudos to him. It's on YouTube. I'll see if I can dig up the link and send it to you.
Yeah, please. Again, it'll go in the show notes here. I'm just thinking of like, you know, a penguin that is black on its back because it blends in with the water, and it's that's the closest I could come up with. And that's
Yeah, he came up with something and using like some, you know, basically some aspects of embryonic development and when things are patterned and stuff. He came up with something for it, or he and his students. It wasn't just him, obviously.
Mm-hmm.
Yeah.
Is there a sci-fi series that does biology really, really well in your mind?
You know, I don't know about really, really well, but I did like Orphan Black. Did you see that?
I did not.
Oh, okay, so this is one that involved like a lot of cloning. There was a lot of cloning associated with it, and I mean, there were definitely some aspects where like, okay, but what was impressive to me is there was a lot of biology and a lot of genetics in particular, and it was clear they had researched it. Like they were talking about individual gene names. They were thinking about how this would work. Clearly, there was a lot of depth in there. I'm assuming they did some pretty hefty consulting associated with that. That, you know, I give them 2 thumbs up, even if it's not 100%. But to some extent, like you said, it can't be 100%. Otherwise, it's going to be a nature story. It's going to be like Animal Planet or whatever.
And I got a bunch of friends that, you know, colleagues, that people who talk to me on Twitter about what happened in the latest episode and how it just broke science. And I'm like, okay, but you have to realize even watching the show at all breaks science. The fact that I mean, you're breaking science from the first frame. It's just how much can you break and still enjoy the story?
Yeah, beautifully said. Beautifully said.
and at this point, we're just looking at, we want to tell a story about people. Yeah, us actually, not people in the present here. And this is just gives us the building blocks to do that.
That's exactly right. I love that.
I mean, science is the part of science fiction that makes the whole thing work, because you know, you're building up. I hate to say what I'm about to say, but it's true. We're building a fantasy world out of real science.
Oh, I know that, and that's fair too. I mean, that's the distinction between pure fantasy, is that you're not doing it out of science. You're just letting whatever happen. Whereas with science fiction, you are actually trying to, you know, apply most of the time some fairly reasonable scientific principles to everything, and not making it too fantastical. Yeah, I respect that too.
Yeah, I do too. I think that there's a tendency to take the science part to the extent that it ruins your enjoyment, which is counterproductive. Exactly.
If there's something that really would make the story much better, do it. You know, forget the science. Just do it. I mean, because it is a story. It's entertainment.
Like how many
scientists out there doing science? We don't need science fiction people to be doing science.
Right. And, you know, to be fair, there are scientists who have decided, hey, I'm going to grab a typewriter and just have a little fun one night, and they've come up with some great stories.
Isaac Asimov, right?
Yeah.
Yeah, and many others.
And at the same time, you know, I like Asimov. Mm-hmm. It's not generally my go-to when I just want to have some fun.
Yeah. It's very grounded. It's very grounded.
What do you think is like his best grounded work? The grounded in the best way possible?
I mean, I haven't read a ton of his work, so I don't know.
Okay.
The few I have, though, are like obviously things like 2001, of course, and stuff. The problem is he's not a biologist, right?
There's a reason I'm asking, and I'm just kind of wondering, have you read The Gods Themselves?
I have not.
Okay. The best thing about this is that when the story starts and it drops you into it, you don't know what's going on.
Oh, well, I love those cold opens. Yeah.
The worst thing about it is you don't know what's going on.
Oh, you eventually figure it out, or is it left vague?
You got to work for it. And wow. I could spoil it if you want me to, because or if not, just get back to me at some point.
Okay.
But yeah, please. I mean, I would hate to ruin it for you, but to understand the world around us, I'd be interested in your response.
Gotcha. So I guess something that reminds me of is like the Twilight Zone. Twilight Zone very regularly would do that sort of thing, right? Mm-hmm. Whereas there's a cold open and you spend the entire episode trying to figure out what's going on, and then only at the end, like, oh.
How about The Outer Limits?
Yeah.
Same sort of thing. Yeah. Longer format.
Yeah.
The difference I always found was Outer Limits almost never had a happy ending.
Yeah.
Twilight Zone's average was a little better.
Yeah. Twilight Zone was like some and some. Yeah.
But we've gotten away from shows like that, the anthology shows where we just let people play with different ideas.
Yeah.
And I mean, even Trek, as much as I love it, when we get into these long story arcs, which are my jam, we get the past, like, well, we know who's here, we know what's where.
Yeah.
And it's
Did you watch in the 80s? Did you watch Amazing Stories? That was one that tended to be a little more positive.
I missed that one.
Oh yeah, that tended to be more, it was like Twilight Zone, but a little bit more positive, a little more family friendly and stuff.
And actually, you're not the first person to bring that one up on the show, so I'm going to have to look into that, because now I've got a sign to go check it out.
It had a great theme song too, or theme music. It wasn't a song.
So what are you working on now? Because the semester is going to be wrapping up soon. You just got back from the cruise.
Yeah. Research wise. So research, I mean, what we're studying, and this is a long-term research project. I mean, we've been working on this for over a year, and we'll be working on it for multiple more years still. In most species, and we're studying this using fruit flies, in most species, lethal causing gene variants are quite abundant. So probably like on average, most people, or fruit flies or whatever, have 1 or 2 gene variants that would cause lethality. But since we only have 1 copy, we're not dead because they tend to be recessive, that the other copy essentially counterbalances it. What we're trying to do is we're trying to understand why are there so many of them and what are these things, right? So this is the kind of thing, it's funny because this has been known for, at least in fruit flies, since the 1930s, right?
Wow.
So it's been known a long, long time.
Sure.
And it was studied a lot in like the 60s and 70s, but they didn't get really far. So this comes back to the question you were asking earlier too. And then what's funny is people just kind of dropped it. People were like, you know what, let's move on to something else. And it was a conversation I had with one of my graduate students about 4 years ago or so. I was talking about this stuff and I was like, you know what? This is much more doable to figure out now using like whole genome sequencing and stuff like that than it would have been in the 1970s by a ton. So I was like, well, why not just write a grant and get the money to do it? And the National Science Foundation graciously funded me with, a big grant. So that's what we're working on right now. And we've identified some of these lethal causing variants. We've shown that they are specifically like single gene variants. Because one concern was that they aren't single genes that are causing lethality, but maybe it's the accumulated effect of a whole bunch of little ones. It's clearly not that. It is clearly single genes. So that's what we're working on.
I'm not the National Science Foundation. I don't know how many papers pass their desk every day. But if you pitch this to me, that sounds like information worth having. That sounds like work worth doing.
Right. And the health implications are huge. The conservation implications are huge. It crosses so many boundaries. So I'm really excited about it. And I have a wonderful team. Fantastic lab manager, fantastic grad student, a team of undergrads all helping out with it. So, or actually not helping out. They're like doing almost all of it.
Very much interested in, is there a way we can follow that, or is it just kind of wait till the paper gets published?
No, it's a wait till the paper gets published. And it's gonna be a
fair enough. Sure. No, understandable, but you got me psyched up, and that's the way my brain works.
Yeah.
Well, I don't want to take up too much of your time because I do know you're a busy guy, but I really appreciate you coming by. And I would like to swing back and maybe check to see if you check out that book at some point. And I'm going to look up that TV show as well.
Yeah, I'll look up the YouTube link and see if I can send it to you too.
Please do.
Cool. Well, thank you.
Okay. Well, everything's going to go in the show notes on my website, aaronbostic.com. Dr. Noor, thanks so much for coming back.
My pleasure. Thank you so much.